Hello everyone, in this lecture we are going to talk about the parallel axis theory for IY. We have again two external axes X and Y, and we have this big area, and we are going to choose small infinitesimal area. We call it the capital A, and X dash and Y dash are two axes passing by the CG of this big area. The distance from the CG to the y-axis we call it x bar, and while the horizontal distance between the CG of the DA to y dash we call it x dash, as we are going to say. This and y bar is the vertical distance from x dash to x. If we are going to estimate the moment of inertia about this y-axis, it is the integration of dA multiplied by this x distance. X distance can be estimated as a sum of two components. This is the x bar, plus this one is x dash distance. All will be squared, same like we have done before. Then the IY is equal to the integration of dA multiplied by the first item, this one x dash squared, plus 2 x bar x dash, plus x bar squared. Then we are going to multiply all these items by dA. So the IY is a summation of the integration of dA multiplied x dash squared plus the integration of dA by 2 by x dash x bar x dash plus the integration of dA multiplied by x bar squared. And all this dA, it means perform the multiplication of the integration by the square of the distance. Similarly, this term dA by x dash square, this is a dA by x dash square. This is a moment of inertia about y dash. This is a moment of inertia about the y dash, plus 2 times x bar, being constant, it will come out 2x bar. And inside the integration sign will be the multiplication of dA by x dash. The dA by x dash is also the first moment of area about the y dash, which is passing by the CG, which is equal to 0 because this is the CG. This middle term will come to 0, plus the integration of dA multiplied by x bar squared will be equal to the capital A by x squared, x bar squared. So finally we have IY equal to the moment of inertia about y dash x, which is passing by the CG, plus the area multiplied by x bar square, where x bar is the horizontal distance between the CG and the external y bar axis. For the IXY, the product moment of area, again the same area and the small strip dA, we are going to introduce x dash and y dash. These are two axes passing by the CG, and the external two axes as usual are x and y. The distance from the CG to the y axis is x bar, while the vertical distance between the CG and the external axis x is y bar. In order to estimate the product moment of area, we need to make integration by the multiplication of dA by the x horizontal distance multiplied by y to both x and y external axes. Similar as before, this x equal to the x bar plus x dash, and the y overall distance is equal to y bar plus y dash. We put both two items inside brackets. Then the IXY equal to the integration of dA. Then we multiply x1 by y1 plus x1 y bar plus x bar y1 plus x bar y bar. These are the four terms inside brackets. Then we are going to investigate each item and see what resembles. The integration of dA multiplied by x1 y1 plus the integration of dA multiplied by x bar y1 plus the integration of dA multiplied by x1 y bar plus the integration of dA by x bar y bar. Since x bar and y bar are constant distances, it will come out dA by x1 y1, this is the dA, and this is x1 y1. This is product moment of inertia about the CG, and we are going to call them I x1 y1. Second term, x bar will come out, then we left with dA by y1 plus the y bar will come out by the integration, will be multiplied by the integration of dA by x1. Both these two terms, since they are the first moment of area about x and y, they are equal to 0 because these axes are passing by the CG. Then these two terms will be cancelled. The last term, which is the integration of dA xy, x bar y bar, will equal to capital A multiplied by x bar y bar. At the end, Ixy equal to the Ix1 y1, and the product of inertia about two axes passing by the CG, plus the area multiplied by x bar y bar. For the polar moment of inertia, this is a new expression. Polar moment of inertia is a summation of the moment of inertia about x plus the moment of inertia about y. And this will be considered as a constant value. What does it mean? It means that for any two arbitrary orthogonal, this is supposed to be 90 degree, the angle should be 90 degree. At first we have x dash, y dash, and then we have chosen two orthogonal inclined axes passing by the CG. The I polar equal to the Ix plus Iy, Ix dash, y dash, moment of inertia if we are going to discuss about the CG, equal to the Ix1 plus Ix2. While if we are going to estimate for Ixy, we are going to say that's I polar equal to Ix plus Iy, which means that again we are going to write Ix1 plus A multiplied by x bar plus Ix2 plus A multiplied by y bar. And if we are going again to select any two orthogonal passing by this two one, and we can call them whatever any name, x and y, capital X and capital Y, then the I-polar again will be equal the summation of I capital X plus I capital Y. There is another term, we call it radius of gyration, for Ix equal to A multiplied by the power of Kx to the power of 2. So we can get an expression that Kx equal to the square root of Ix divided by A. Similarly, Iy equal to the area by Ky to the power of 2, which means that also Ky equal to the square root of Iy divided by area. We will consider that the area, for example, for a rectangle, that area is concentrated at the CG. For the case of the first moment of area, we'll find out that when area is concentrated at the center of gravity, then the first moment can be estimated at the multiplication of the area by y bar, which is a vertical distance to the x-axis. While the difference between y bar and kx lies that the location of the point will be considered changed, and the multiplication of the area by kx squared will produce second moment of area. That's why Ix equal to the A multiplied by k squared x, after considering that the concentration of area, they are different between the two cases. For the rectangle BH, the CG lies at y bar, which is equal to h over 2, while for the second moment of area, we consider that the area is concentrated at a distance equal to kx. Thanks a lot and see you for another topic. Goodbye.